My name is Dr. Daniel Haders, and I'm the Executive Chairman at Model Medicines. Today we kick off part one of my four-part conversation with Dr. Sumit Chanda, Director of Inflammatory and Infectious Diseases at Sanford Burnham. Sumit, I'm excited that we have just publicly announced a partnership between your lab, Sanford Burnham, and Model Medicines to discover therapeutics for new antiviral targets that your lab has identified. However, before we discuss the partnership, I would love if you could give our audience background about you and your lab's accomplishments, specifically starting with your leadership in HIV.
Yeah, our lab has been working on understanding how viruses, including HIV, interact with the host and using that knowledge to really develop next generation innovative therapeutics. And so our lab has really provided some fundamental insight into what are called host pathogen interactions for HIV, and then have now applied that to things like influenza and COVID and West Nile and dengue, right? We really take a top-down approach, which involves harnessing big data by generating systems-level technology. So these are omics-based data sets, things like CRISPR, things like proteomics, things like RNA-seq. So grabbing as much of the big data as we can so we can get a 20,000-foot view and then distilling that to actionable biology that we can understand mechanism and develop novel therapeutic interventions for these diseases.
COVID-19 was only discovered and then characterized in late 2019 and early 2020, respectively. So how is it possible for you and your lab to pivot from HIV and other viruses, which you have spent your career studying, to COVID-19 so seamlessly?
So it's an interesting question. So I think the common thread here is the platform technologies that we use. These omic technologies are really agnostic to the virus or the disease, whether it be high throughput screening or proteomics or CRISPR. It doesn't matter what the virus you introduce onto there. And there are lessons from host pathogen interactions that we've learned with HIV, that we've learned with flu, that really had us prepared to be able to apply those to our understanding of COVID. So that really, if we had started from scratch, there's no way that, we would have been able to make the progress we did in the last year or so. But, this is really a reflection of the investment that, our government has made and different pharma companies have made into my lab that allowed us to take the lessons learned from HIV, from flu, from dengue, and then move them quickly into COVID to develop new therapies and new understanding of what you're saying is true, a brand new virus. But these viruses, they can be brand new. There are commonalities between almost all viruses, right? And so it's not the same, but the fundamentals can be really translated between the viruses, and then you launch from there to gain new insight, both in the therapeutic and mechanistic space.
Very interesting. So where do we go from here? Is COVID-19 the end of the book for the global population, or is it actually the end of chapter one in a new book for a new world with new normals? A world where the global population will need to accept that global viral outbreaks may or will become something that we're going to have to regularly coexist with.
So I think that definitely the latter. So nature has been trying to warn us, I would say, since the early 2000s, right? So there's, I think, a confluence of things that are happening, right? People are traveling more. People are encroaching into areas where these, what are called zoonotic viruses, or viruses that can jump from animals to humans, they're encroaching into those areas more. There's more interaction there. There's more trade in this wildlife that can carry these kinds of viruses. And people are traveling more, much more of an interconnected society. And so if you start thinking back from the early 2000s, right? So we had this first SARS, right? Then we had flu, and then we had MERS, then we had Zika, and then we had Ebola. The frequency of viruses with pandemic potential. And unfortunately, those viruses really didn't take off, right? But nature is relentless, and so one of these we're going to break through. And the more shots on net you have from a virus standpoint of causing the pandemic, the more the likelihood of that happening. So what we're seeing is historically there is really a much more frequent occurrence of these pandemic events happening, potential pandemic events happening. So you can think back, for those people who are young enough to go back into the 80s, we had HIV and we had kind of sporadic outbreaks of Ebola, and then we had some flu pandemics, but not nearly at the frequency as we're seeing them. So I think that we're really setting ourselves up by our own activities for being susceptible to these pandemic events, these zoonotic events that can lead to pandemics at an increasing frequency. So unless we instill both surveillance measures and therapeutic measures to be prepared for the next pandemic, we're going to be resigned to not only repeat this last episode, but even going into a worse standpoint where we could face a much more deadly and contagious virus that could have a longer term impact on global health and the global economy than even SARS-CoV-2, which was devastating enough, but it could have been worse. It really absolutely been worse from a virological standpoint.
I agree. In behind the scenes conversations I've had with leading clinicians, public health experts, epidemiologists, and other virologists like yourself, the one thing I've been told over and over again is that we got lucky. It's difficult at a human level to process the concept that, quote, we got lucky when over 3.5 million people globally and over 500,000 people in the US have lost their lives to the COVID-19 pandemic, and the global economy was brought to its knees for over a year. However, I now understand that it could have been worse. The virus could have been more contagious. Its incubation time could have been longer. It could have been deadlier. It could have targeted children preferentially. The scary thing is that the next pandemic could be all of those things, right?
I think the other thing people need to be aware of is that we got very, very lucky with this vaccine, right? This vaccine is going to save us. Probably, we have 3 vaccines that are now approved in the US. But we got lucky that these vaccines work as well as they do with the safety profile that they have. Now, if you look at HIV, which has been around since the early 80s, we still don't have a vaccine for HIV that works, okay? If that was the case with SARS, we would be looking at a much different reality right now. Everyone's really on the edge of their seats in California. We're going to open things up on June 15th, and that's made possible by a vaccine that is highly efficacious and safe. That is not always going to be the case. And we've seen that historically, right? And so unless we prepare for a future where we invest in vaccine development, and therapeutic development, we are really laying ourselves open to being ravaged by another pandemic, in which case that, we may not be able to make a vaccine in record time like we did this time around.
Point well taken. And importantly, vaccines cannot be developed for a virus until after the virus exists. Thus, vaccine development will always be a reactionary countermeasure rather than a proactive solution to future outbreaks. It sounds like you are making a definitive case for the idea that if we want to be prepared for future pandemics, one of the cornerstones of that preparedness is that we must develop broad-spectrum antiviral therapeutics that can be delivered in an outpatient setting today. Going a step further, it is not simply good enough to have created those therapeutics, but they must be manufactured, distributed, and available globally before we even know that the virus is in a population, right?
Absolutely right. So, there is this mantra that's going around that none of us are safe until all of us are safe, right? And so this is especially true for viruses, right? So we can sit here and say, okay, pat ourselves on the back that, California and the US has done great with the vaccine distribution. But, what we're seeing is that the emergence of these variants coming out, and eventually the virus will find a way to evade vaccine and immunity like it does to evade different drugs. So it's important that we have treatment and therapeutics and vaccines available to the entire world. For an antiviral, you want something that you can store at room temperature, the supply chain doesn't require an exorbitant amount of, refrigeration and expertise. So you want that to be orally bioavailable. Ideally, you want something with prophylaxis. So if we had prophylaxis for SARS, right, even a post-exposure prophylaxis for SARS, where you give it to people at the early stages where you can cut down transmission, right? The easiest time to squash fire is when it starts, not when it's out of control, right? And I think that a prophylactic therapeutic will play a large role in this, because it will not only help people get better, right, but it should also cut down the window of transmission where people actually can transmit the virus to fellow citizens. And if we can do that at the site of where the initial outbreak happens, right, then that will be a much better option than trying to treat everybody in the world. But we still want that, right? So if that fire breaks through, we need multiple different fire lines here. And part of that strategy really needs to be therapeutics, whether they be prophylactic therapeutics or therapeutics for treatment. Those are things that we need to stockpile, right? We need, the analogy that we like to use is that we spend billions on weapons in the army and the military that we never use, nuclear weapons, and we hope to God we never use. But the flip side, the downside risk of not having those is so big that as a society, we say, okay, we want to spend billions of dollars for this kind of eventuality that may or may not happen, right? And now we need to do this for virus and pandemics, right? We need to spend that scale of money, that kind of investment, because these, I think, at this point, it's going to be hard to argue that this is not an existential threat. And we need to stay serious as we take terrorism, as we take potential attacks from our enemies, because this disrupts not only global health, but our way of life. And, most virologists don't see this any longer as a once in 100-year event. These once in 100-year events, whether they be hurricanes or forest fires, are all being compressed. And the same is going to be with pandemics, and we need to be prepared, and we need to be ready to make the investments that allow us to be prepared, both as a society, as a government, and as a planet.
Well put. To sum it up, a government cannot govern and civil society cannot exist if large portions of the global population are constantly at risk of succumbing to pandemics. This may sound dramatic, but in that reality, children cannot go to schools, supply chains break down, economies fall apart, and the fabric that holds us together as citizens of individual countries and the globe dissolve. I do not know how others might define an existential national security threat, but to your point, I would define it as exactly that.
We're all so interconnected that it won't happen here is no longer, I think, a reasonable argument to be made in this front.
We will end part one of our discussion on that terrifying note. In part two of our conversation, I will look forward to speaking more about your work in COVID-19. Let me start over. I got my rhythm off. We will end part one of our discussion on that terrifying note. In part two of our conversation, I look forward to speaking more about your work in COVID-19 over the last year and a half and learning more about your approach to identifying broad-spectrum antiviral therapeutics that could solve not only this pandemic, but the next one as well. Thank you so much for your time, Dr. Chanda.